Okay, so I'm Saina. I'm working as a BIM application engineer in BIMLABS Global. So uh, today I'm going to take a session with the topic Introduction to BIM tool, Revit. So let me introduce about our BIMLABS. Our institute BIMLABS is situated in Kerala, southern state of India. And BIMLABS is an Autodesk learning partner and member of IGBC, Indian Green Building Council. And our business areas are listed here. This BIM training for students and corporates, BIM implementation support for corporates and organizations, BIM project outsourcing, and BIM placement services. For more details, you can access this mails also. Okay. WhatsApp, mail, Facebook, Instagram, website, LinkedIn, mail IDs are also given here. So this is our company details. These are the certifications that our company has. And more about our company, our corporate office is situated in Karakotam, Trivandrum. And we have two branch offices, one at Statue, Trivandrum, and another at Cochin. And we also have a branch office in Calicut too. And we have another office in Dubai also. We have two franchises, one in Kollam and other in Calicut. Okay, so as I said, today our topic is about introduction to BIM tool Revit. So before going into deep into that topic, we must know about firstly we must know about some project stages, isn't it? Firstly, whenever we are going to construct a building or any other structures, there are several stages are also there, and some of the major important stages are provided here. That is design stage, building analysis, project management, documentation, construction, and operation. And in design stage, the design stage is subdivided into two, that is conceptual design and detailed design. And the conceptual design means it's actually the concept of the client. The concept of the client is represented through that conceptual design. For example, if you are going to create a building or any other structure, for example, I'm going to create a type of building, and I have a concept that it should be it should be a type of a commercial or either sorry, residential or any other type of building. And I have a concept that my building should be look like this, and some other concept should be in my mind. That concept should be demonstrated in the conceptual design. And next is the detailed design. Detailed design means it is the integration of the detailed designs of different disciplines. Okay, actually we have in our construction stages, we have total 6 disciplines. That is architectural discipline, structural, mechanical, electrical, plumbing, and coordination disciplines. And the once again, okay. And these disciplines are integrated together to get detailed designs. And the next stage is the building analysis. For getting the detailed designs for detailed design, we must the building analysis should be go parallel to our design stages. Okay, that means building analysis means the analysis of our building of every disciplines in every aspects. Okay. For example, in here the building analysis, it is given that structural analysis, energy efficiency, and the lighting analysis is given here. Structural analysis means in case of structural analysis, through the structural analysis, we can calculate the loads of the building that they could bear, or the how much load the building will bear or how much it is feasible, that building is feasible, etc., can be calculated from the structural analysis. And also the result of structural analysis, it's sorry, from the result of the structural analysis, we can confirm which type of footing is needed, how much reinforcement is needed for our building, or etc. So that structural analysis should give the structural detailed design. That's why I said that the detailed design and the building analysis go parallel. Okay, next one is energy efficiency. I think you are familiar with that term, energy efficiency. Uh, Actually, there is a study that reveals that buildings are the main emitters of some carbon emissions. That means buildings are emitting almost a 50% of carbon, sorry, 40% of carbon in our environment. So we must reduce that type of uh, harmful emissions from the building. So in the energy efficiency stage, we are just in this stage we are just but sorry. It is in this stage we will identify some methods to reduce the emission of such gases by buildings, and this will comes under this energy analysis. Okay. Energy efficiency of a building is mainly depends upon the vegetations they are available, the landscaping of that building, etc. So with our BIM softwares, we can analyze the building energy efficiency with building currents, location, and material used. And IGBC is also recommending lots of material for making our building energy analysis, such as AAC, aerated autoclave blocks. That block is actually a hollow. Inside that block, the portion is hollow, so that thermal conductivity will be less, and we can reduce the use of some extra energies also. And similarly, in lighting analysis, we can through our lighting analysis, we can make our building much more what much more eco-friendly by uh, placing windows near windows, using natural resources. One second. Okay. Next one is the project management stage. In this stage, there are three components are there. That is time, cost, and resources. Actually, what the time, cost, and resources in the project management mean is through our BIM software, we can calculate the time that they need for completing our building model, and the cost that we actually needed for completing our project, and the resources. Resources means men, material, and labors, etc. So, and these three components, that is time, cost, resources, can be managed within this project management stages. And next one is the documentation stage. Documentation stage is actually the what it consists also three types of documentations, that is approval, shop drawings, and as-built. Approval is actually we can say it as sanction drawing also. That is, before constructing our building, we must need an approval from our government. And after receiving that approval, we can do what our construction, we can start our construction processes. Okay. And in Kerala here, it is approval is sanctioned by with rule KMBR rule. And after the approval, we can start our what construction stages. Next one is shop drawings. It is actually we can set it as a site drawing. Actually, the engineers language is much complicated. It is very difficult for the laborers in the site to understand. So we will provide a detailed drawing of our building or the proposed project, which is much more easy in the form of with a simple form, so that even the laborers in the site can understand what what the details of our building from that drawing. That is called the shop drawings. Next one is as-built drawing. Actually, as-built drawing is the drawing that we kept even after the completion of our construction. That is construction of our building. We will keep up a drawing of our a detailed drawing of our building for the purpose for future maintenance. Okay. Next one is construction stages, and in this construction stages there are two stages are given, that is logistics and commissioning. Logistics is a method or it's a stage uh, which ensures that the uh, materials, labors, and the time, resources, etc., are available, and the work is going properly. And that is the stage called the logistics. It is in this stage that we will check whether the work process is going properly. And next one is commissioning. It's actually comes up just before delivering our project into the client. That is, in this commissioning stage, they will the commissioning team will check whether our building is constructed properly or not, whether the equipments inside our building is working properly, the quality of tile is correct or not, etc. is done in this commissioning stage. Next one is operation and maintenance. Actually, after the completion of our work, construction work, and we need to maintain them. Then only we can use our building throughout the building's life. Okay, so these are the main project stages that comes in the construction field. So now I'm going to tell you about the BIM tool, which is used in the detailed design stage, that is Revit. Before that, I am going to tell you about the evolution technology from hand drafting to the building information modeling. We all know that in hand drafting, there are so many drawbacks, isn't it? We have to draw the plan in different papers, uh, and we need, if there any error occurs, we need to rework. So it will be more difficult and it is more time consuming. And okay, that is given here. It is a small correction is number of updations in different sheets. Already said that there are different disciplines in our construction field, and the architectural model will be drawn in a single paper, and another construction drawing may be drawn in another single paper. If there is any error in an architectural model, it should be corrected in architectural model as well as other discipline work sheets also. So it will take more time, and the coordination and clashes cannot be identified or rectified through that hand drafting method. And time management is also not in our control, that we can't control the time of construction period or any other thing through the hand drafting. And next one is cost estimation, and cost estimation can done only manually, and there will be surely will be there some errors should be there in cost estimation through manual estimation, and also no way to analyze the energy efficiency of the building. So that these are the drawbacks of our hand drafting. So we just need a better workflow. That's why we move on to the next workflow, that is called a CAD. CAD workflow. CAD is actually called a computer-aided drafting workflow. And in computer-aided drafting workflow, it is much better than our hand drafting, but even though it has some drawbacks. Okay, such as in CAD workflow, we can create the sections, elevations, floor plans, etc. But it take, for example, if I drawn a floor plan and also drawn elevation sections, etc. But whenever if there is a change in the floor plans, we must need to update it in the elevation sections and detail views separately and manually, so that it may take some times also. So these are also the drawbacks, and also we can't control the time of our construction project or budget, etc. So we need another better workflow. That's why we end up to the building information modeling. That is the new technology. Okay. Next, I'm going to tell about the Revit. That is actually a BIM tool. Okay, the purpose of Revit is it is actually a tool which is work with the technology building information modeling or BIM, and it is usually used by architects, designers, or engineers, etc. There are some file formats are available as there in Revit. Mainly, there are two types of file formats are available. First one is project file format, and then another is family file format. In project file format, we have two type of file formats, that is .rte and .rbt. Actually, the .rte file extension is used for the project template. Okay, I will tell you what the template is. Actually, the template is a workspace that I will tell you with an example. I'm going to create a architectural model. Okay, so I need a environment which supports the designing of architectural model. So such architectural modeling can be done with the help of such a architectural template. Similarly, if I want to create a structural model, I need an structural template. Actually, template means an environment which is with it is actually an environment which contains proper tools for designing that particular project. For example, if I'm going to create an architecture model, the architectural tools are arranged in that architectural template. If I am going to create a structural model, the structural template will be choose it, and the template will support the tools which uh, tools for creating the structural model. Okay. And that template file format is .rte, and next one is the project file format is .rbt. What is the project file is means, I already said I'm going to create an architectural model, and with this project template, this architectural template, and that architectural model file should be saved in the format of .rbt. Okay. Next one is family formats. There are two types of family formats is available. First one is .rft and next one is .rp. Similar to the project template, we have also a family template is there, and it is actually for creating a family. What family means is in Revit software, each and every component in Revit is family. For example, uh, in AutoCAD, we will draw a wall with the help of some two lines, isn't it? The wall is represented with the two lines, but in Revit, it is actually a wall. A component is there for separately for walls, windows, or etc. I will show you with our Revit software. Okay, this is the Revit interface. I will detailedly explain after this presentation. Here, I said that already. We have each and every component arranged in separately. For example, all components are available here, door, window, etc. All others are separately given. These are the tools for creating the walls, windows, doors, etc. And each of these components are said to be families. And for creating families, we must choose the family template, and that family template's file format is .rft, and the family template that I created with the family project that I created with the help of family template is saved with the file format of .rfa. Okay, so these are the file formats of Revit software. Next, when we move on to Revit deeply, the main peculiarity of Revit is that even from a single floor plan, we can automatically generate elevation sections, 3D views, legend views, and schedule and quantity takeoffs. That means uh, in our software, whenever I'm going to create a wall, I'll show you. Okay, I'm just creating a wall like this. It is actually in a plan view, but I just really created the plan view of our wall. But it will automatically generate the 3D also. I will show you the 3D of this wall that I created. So simply we can say that by simply drawing the uh, floor plan itself, we can automatically generate elevation sections, 3D views, legend views, and scheduler quantities. I will show you what is elevation sections, etc. Okay. Next one is, okay, I will explain each of them. First one is plan views. Plan view is a two-dimensional views which provides a traditional method for viewing a model. These views include floor plans, reflected ceiling plans, and structural plans. This is actually a two-dimensional view. That is, I already done in Revit. I already shown you the floor plan of a particular wall there. That is the plan views. Next one is the elevation view. Elevation view is actually which represents the height of or the elevation of our building. That is the elevation view. We can automatically generate that elevation view from the plan view itself. Next one is the section view. Section view is views cut through the model, and you can draw them in plan view, section view, elevation view, or detail view. We can draw the section view in all these views also, and the section views will displays as section representation in intersecting walls. Okay. Okay, I have a model here that is done with the Revit software. This is a 3D of our that model. Okay, if I need to know the elevation of this building or need to see the elevation of our model, we can go for the project browser option here, and we can see elevation option in the project browser, that is east, north, south, and west. If I want to see the elevation, south elevation of this model, we can easily navigate into that south elevation by double clicking on it, so that we will get the south elevation of that our building, so of the same building. If you want to see the north elevation, we can easily navigate to the north elevation through the project browser, and we can see the north elevation. Okay, that's how it's simple to get the elevations of the four sides of our building, four elevations of our building. Next one is the section. If you want to cut the section of our building, so for example, I am going through the floor plan. Here we can see floor plans, elevations, 3D views, etc. in the project browser. This actually the use of the project browser is we can easily navigate from one particular view to another particular view. That is the use of the project browser. And we can see another option is also available here. That is the properties. Actually, property means the details of the component can be seen in the properties box. For example, if I choose a wall from here, if I choose this wall from here, we can see the details of that wall. We can see the section of that wall and its level, from where to where it is, the wall is constructed, and each and every details can be seen in the properties box. Its length, area, wall, etc. can be seen here. And so if I want to create a section of this particular building like this, for example, if I come to the south elevation and I want a section of this particular view, I can make sections like this, and I will get this section of this particular view in the section option in the project browser. This is a section of that particular view. So it is very simple to generate section, elevation, and other views from a single floor plan itself. Okay. Next one is the 3D view. Actually, the 3D view can be seen by clicking this default 3D view icon, so that we will get the 3D model of the entire building. Next one is legend views. Actually, what is legend means? It is a list of building components, and annotation that we used in our project. Similarly, we can create a list of building components that we used for the entire buildings through Revit software. That is called the legend views. It is actually very easy to create this legend views using Revit software. Next one is schedule or quantities. Actually, schedule means we can take additional data such as the number of those that I placed in my entire project, its count, its cost, its levels, that in which level that I placed that dose, etc. can be taken from that schedule options. Actually, not only for the door schedule, it is actually we can create schedules of doors, windows, walls, and each and every component in our building. Similarly, window schedule can be created there. Sorry, created here. So this is the user interface of Revit architecture. Okay. This is the user interface of a Revit architecture. This is properties panel, and this is the project browser. And this is called the ribbon tab. This one is called the ribbon tab. Okay. Here it is given more clearly. The icon with the Revit logo is called the application button, and the tools arranged near to that application button is called the quick access toolbar. Next one is ribbon tab, and ribbon under the ribbon tab, under the tab, each of the tools is arranged in separate panels, and this is the properties palette and the project browser. This is the view control bar. This is the drawing area or the workspace. So here we can say that this is the application menu of Revit. This is the application button. This is a quick access toolbar. This is the information information center. This is ribbon tab. This portion is said to be ribbon tab. This is properties panel. This is the workspace. Okay, these are all about the interface of Revit. Then when we move on to the detailed design using Revit, we can place intelligent elements like walls, doors, windows, etc. We can simply place walls. In walls, there are different types of walls are available. That is normal types of walls, stacked walls, and curtain walls. We can simply place the walls where we want to place it through Revit. I will show you. I already drawn a wall here, and actually it can be set as an host element. It is set to as host element. Why? Because some of the other components which are based on the host elements can be placed only if there the host element is available. For example, door is a host based element, and the door can be placed only if there is any door is available. For example, if I want to place a door, we can simply place where there is a wall. If I want to place a door in any other portion with the no walls, we can't place them, and we can place them only where the wall is available. Okay, so that the wall is set as host element, and this uh, doors, windows, etc. are called as hosted elements. Okay, they can be placed only where the host element is available. So we can place the walls. We can place doors, windows, and components as I shown. and we can place stairs, rails, and ramps. We can create different types of roof. We can create ceilings and openings. We can also create floors of different with the different material, different layers of materials. We can also create some families. For example, in our Revit, I just simply place a door that is already available in our library. This door was actually available in our library so that I can place them. If you want to create another type of door, okay, I will show you. I'm just simply placing the door here, and whenever I go to 3D, we can see the door type that I placed here. So this is a type of door that is available in the Revit library itself. So if you want to create another door with your own idea or your own design, we can create it. Not only the door, we can create furnitures, windows, any other families can be created by ourselves. And that type of families can be loaded into a project and can be placed in our project. Okay. So that is given here. We can add families. It's a group of components used to build a model. For example, walls, windows, stairs, doors, bathrooms, furniture. Each of every components can be created by ourselves through the family templates. Okay. Next one is managing materials, paints, and etc. We can provide paints to our walls. We can also provide some gradients, paints, etc. to our wall for more aesthetic appearance. Next one is we can create the landscape. We can create the topo surface for our building. For example, here the topo surface is already given here. It is actually for given for more aesthetic appearance. We can place green grasses there. We can place side components such as trees, uh, peoples, etc. here. It is actually for making the building more attractive, and it can be done in the Revit software. Next one is the schedule and material takeoff. I already said what is schedule and material takeoff means. We can take the uh, data, we can collect the data from our model about the number of walls, wall length, number of doors, windows, and other schedules easily. Next one, we can prepare documentation. Okay, documentation means sheet setting. And we can simply place the sheets, we can simply place plan views or any other views into sheets through our Revit software. I will show you after this PPT presentation. Next one is visualization. You can use Revit architecture to generate a real-time rendered view of a building model using the realistic visual style, or you can create a photorealistic image of the model using the rendering tool. That is, we can create a rendered image of our building model through the Revit software. Okay, I will show you how can we create such type of rendered images, how can we create schedules from our building, etc. So if I want to create the schedule of a door, we can simply uh, create it with the help of schedule option from here. And we can, if I want that door schedule, I can choose the door schedule option and we can add the details that we needed. I'm just adding some of the fields I needed. I'm just adding these 3 fields so that we will get the D1 doors. So many doors are placed in this entire floor plans. Uh, totally 121 doors are placed in this 3D plan itself. Sorry, not this 3D plan. This 3D model itself. Totally 121 doors are available here. Similarly, we can take the window schedule, wall schedule, etc. Next, we can also create the section. Here, the section is actually in a 2D format. If you want to make them in 3D, we can simply make it 3D. For that, I'm just going to the 3D view. Sorry, it's a 3D view. And if I want that section view, or I want to see that section view on the 3D, we can go to orient to view option and you can choose a section view so that we can see the section view in 3D. So in short, we can say that Revit is actually a simple and more interesting software to create our own designs, and we can generate automatically the 3D views, section views, floor plans, etc. Okay. And I will show you a demo of how to create a rendered image from the Revit software. I already done two rendered images here. I'll show you that two rendered images. This is the rendered image of our building's front view. And this is the rendered image of the sectional view that shows the furniture arrangement. Okay, I will show you how can we create another 3D view, 3D rendered view. So that I'm just going to place a camera path. Okay, so if I want to create the rendered image of this particular view, we can make it simply by clicking a rendering option. After the completion of rendering process, we will get a rendered image of this particular view. This is the rendered view of this particular view. And this is how much simple we can create the rendered images also. Next, we can move on to some terms that is commonly used in Revit. That is actually, these are the normal or common terms that we usually used in Revit. That is project, level, element, category, family, type, and instance. Okay. First, we will go through project in Revit. It is actually the file of our model in RVT file format, and it is a single database of our design information, which includes the components used in our project, such as walls, doors, columns, views of the project, and a drawing of the project. And the main property of Revit is that it enables to alter the design that changes and alter the design, and that changes will reflect in all associated areas such as plan views, elevation views, section views, and schedules. That means if I make any change in the plan view, it will automatically update in all other views such as elevation view, section views, and all other views. Okay. That is called the project in Revit. Next one is levels. Levels are actually horizontal planes that act as a reference of elements such as walls, roof, etc. That means in case of a wall, if I construct a wall which starts from a plinth level to the rooftop level, so that we can so that reference can be set with the help of the levels. So that means if I want to create a wall from the plinth level to the rooftop level, we can set the levels such as plinth level and the rooftop level, and we can assign the limit of that wall elevation from that levels. That is called the levels. And the levels can be created only in section views and elevation views, and we can't create the levels in any other plan views or etc. Next one is element. In order to complete our building model, we must need to add parametric building elements to the design. For example, in order to complete our building model, we must need to add wall, door, window, etc. So that is called the elements, and the elements are classified into category, family, and type. Here an example for the element classification in Revit is given here. The category is said as duct. Duct is actually a category, and there are two types of uh, ducts is available. That is family, that is round and rectangular, and these categories are said to as family. That means the purpose of this duct is actually same, but the name is different. Only the name is different and its shape is different. The purpose is actually the same, so that it can be said as a family. And next one is the type. That is the difference between the family and the type is, in the type we can what it will gives the details of its dimensions also. For example, in a round text, we can see round text with the 400 mm dimension and a 600 mm dimension. Similarly, in rectangular text, text with the different dimensions are available. So that we can say elements are classified into category, family, and type. And the family, category, and type is detailedly described here. Group of elements that used to model or document a building design is called a category. Model element categories includes mechanical equipments, architectural elements, air terminals, etc. Categories of notation elements also includes tags, text, and notes. And next, what is family is a group, a group's element with a common set of properties with the identical uses. I already said the duct is actually for the same purposes and a similar graphical representation. Only the shape or any other value is different. That is called the family. Next is the type. Type with the family can have several types. Type can be specific size of family such as duct with a 300 by 300, 400 by 400, etc. That is the classification of all the family of elements in the Revit. This is the element hierarchy and behavior in Revit. Revit element is classified into model elements, datum elements, and view specific elements. And the model elements is splitted as host and model components. That is, host is actually, I already said some of the components are host. That is, walls, roof, ramp, etc. are actually a host. And some of the components can be placed only if there is the host is available. That type of component is said to as model components. Next one is datum elements, and the categories come under the datum elements is uh, grids, levels, reference places, etc. And next one is view specific elements. And the under the view specific elements, annotation elements and the details elements are there. And the annotation elements means text notes, tags, symbols, dimensions, etc. And in detail, uh, detail lines, filter regions, 2D detail components are what classified. Detailedly, we can say model elements. It represents the actual 3D geometry of the building. They display in all relevant views of the model. There are two types of model elements. That is, I already said that it is a host element and a model components. Host elements are generally built in place at a construction site. That is, it is already construct built in the construction sites such as walls, ceilings, and etc. And the model components are the components uh, which is all other than the host elements are called the model components. Example, sinks, boilers, sprinklers, etc. Windows, doors, etc. comes under the model components categories. Next one is datum elements. Datum elements helps to define project context. For example, examples for datum elements are grids, levels, reference planes, etc. Next one is view specific elements. These view specific elements display only in the views in which they are placed. We can't see them in other views. We can see them only in the views that we placed, and they help to describe or document the model. Uh, there are two type of view specific elements, that is annotation elements and detail elements. And the annotation elements are 2D components that document the model and maintain scale on paper. For example, dimension, tag, keynotes, etc. And these can be done in the Revit itself. And next one is the details. Details are the 2D items that provide detail about the building model in a particular view. For example, the detailed view of our footing, detail line, detailed view of footing includes. It can be done with the help of detail lines. That is, detailed view of footing can be done with the detail lines. Filled region. Filled region is actually the it is used for creating hatch areas for a particular region and the 2D detail components. Next one is family. Family is a group's element with a common set of properties, identical use and similar graphical representation. In Revit, there are three types of families are available. First one is system family. Next one is loadable family. And third one is in-place family. The difference between three families are clearly demonstrated here. First one is system family. System family is predefined in Revit and have predefined parameters. It can't be created or deleted. Example for system families is duct, wall, pipe, etc. And we can't be created or deleted, but we can edit and create new types from the existing predefined types. We can't create a new one. We can create a new type by editing and duplicating it. That is the system family. Example is wall, duct, pipe, level, etc. Next one is loadable family. Loadable family can be created from family templates and load into projects. That is, I already said if you want to create a door with our own design, we can create it separately and we can load them into our project. That door will comes under the door loadable family. Not only the door, windows, furnitures, ducts, etc., plumbing fixtures, etc., comes under the loadable family. Next one is the in-place family. In-place family is actually the custom elements that is created in the context of the project, context of a project, and can be used only in that particular project itself, and cannot be loaded to any other project or any other file. And that in-place families can be used only in that specific particular file. And they are created when the project needs unique geometry that you don't expect to reuse, or geometry that must maintain one of more relationship to other project geometry. You can place copies of the same in-place elements in your projects, but we can't transfer this in-place family to any other projects. Next is the levels and views. What's the difference between levels and views is, actually I'll show you. Okay, here in the project browser, we can see floor plans. Floor plans and here this is the views. That is, in floor plans, we can see different floor plan, first floor plan, second floor plan, etc. East elevation, west elevation, etc. These are actually the views. They're actually the views. And the levels means, I already said that the levels are actually used to define the elevation of our building component. For example, if this wall, whenever I pick this wall, we will get the detail, that is, it is started from the ground floor plan and it is ended at the first floor plan, so that we can set the height of our building component or the elevation of the building component. That is the use of levels. And the floor views are the floor plans and the ceiling plans, structural plans, etc. That is the difference between levels and the views. The levels couldn't be duplicated, couldn't be deleted. Deleting level will cause all elements reference to that levels to be deleted and couldn't be restored. Any project should have at least one level. We can't create any other project without any levels. So we need at least one level to develop our project. And each level produces two types of views: floor plan view and the ceiling plan view. And views could be duplicated. We can duplicate any numbers of our view and could be deleted or restored. deleting any view has no effect on the elements, but whenever we delete the level, it will cause all elements referred to that level to be deleted and couldn't be restored. So that we can say that level is much uh, more important, that we should not delete the levels, because it will cause all other elements to or elements referred to that level should be deleted. Okay. Okay, is there any question? Hello? Is there any doubts related to this topic? Okay, so kindly fill this feedback form that I put in the chat box. Please fill that feedback form. And if you have any doubt related to this topic, you can ask me. Okay. Is there any doubt?